instrumentation system for process industry. So why we talk about safety? So it is basically we want to avoid disaster. Okay, but most often accident is unavoidable. Okay, sometimes you have like prepare yourself or make everything in place. Okay, accidents will happen, but the severity of the accident will basically depend on our preparedness. Okay, so this is an example. An accident happened in Flixborough, England, in June 1954. So there was an explosion. Uh, the, so it's not because they don't have a system, okay, but sometimes, okay, they fail, but in this some of the cases they fail to do the risk assessment. Okay, risk assessment and provide the proper mitigation process. So the issue is that they don't have a proper or way on how to define the risk, okay, or the risk in the process. Okay, and then the risk is the calculation from the identified hazard. So that's another thing lah. Okay, so this example is Flixborough, 1974. Okay, cause um, the disaster where the blast, okay, cyclohexane vapor the ignited making a blast equivalent to 50 ton of TNT, causing 28 people killed in that incident. So the cause is that the faulty temporary piping design by poorly qualified design team. Okay. So that this is because they fail to identify the risk. Okay. Uh, during the maintenance. Okay. In this case, they have the system in place. Okay, but so they have when they do have maintenance, and then they don't have a proper process how to do the maintenance. So the accident lead to the control of industrial major incident (SIMA). SIMA, I think, is under the OSH Act. So this is the regulation. This is the latest one is in 1995, if I'm not mistaken, the regulation under the Occupational Safety and Health Act. Let me check. (1996). Okay, so it comes with the regulation, okay, to control of industrial major hazard. So there is with SIMA, okay, they have, okay, they now with SIMA they have standards or regulation where what should a process or company do okay after a disaster so they need a preparation of. There are other cases. In Italy 1975, so uh, incidents so caused by management failure in the post-accident phase lah. So the accident, okay, maybe happen unexpectedly, but to the fail to anticipate, okay, the action after the disaster. And this in 1975, the reactor problem in the reactor, but there's no death or injury. The cause is inadequate control room instrumentation and poor emergency response. So there's are two things here. This is for engineering. Okay, they control asset control or asset or management. Um, so instrumentation is is an engineering step, and poor emergency response is basically done by the management. And so basically the system itself may provide a safety layer, and then if they have a emergency response, it will help to mitigate the problem. Okay, so and Bhopal also one of the incident in 1984. So the incident basically caused 40 ton of methyl isocyanate is spread for 2 hours at kilometer radius over the city. City is have about 90,000, 900,000 inhabitants. More than 3,800 people died and 11,000 disabled. So the cause is that the management failure, poor management, okay, and then disable safety system. I think you go to the YouTube, you can find the Bhopal incidents. Okay, many people die during their sleep, and people when they're disabled, they're basically blinded or have the uh, permanent disability in the respiration system. Uh, the other example I can put is right. So one of the important things in safety is the hazard analysis. Uh, so basically, safety is a process of that will not endanger human life or the environment. The purpose is to main purpose is to protect, okay, uh, the human life or the operator or the worker, okay, and actually uh, or the assets. Okay, not only the environment, also your asset, your structure, your buildings. Okay. So the most important mechanism for improving safety is to identify the way which it can cause the harm, okay, or the hazards. Okay, so like I said, hazard, okay, may basically damage your properties, and also can cause loss of life, release of or wasted energy, and the release of dangerous material to the environment. So basically, hazard. So now there's a new term here. Hazard are the states that we have to avoid. So okay. What is hazards? Hazard is situation in which there is actual or potential danger to people. Okay, situation. And also a hazard is state of set of condition of system that together with the condition in the environment system will lead to unavoidable or to accident. There's the two terms here. Okay, it can be independent situation that is dangerous, or they may have pose a potential danger to people, environment, or asset. Like for instance, uh, object at height. Okay, so it have a potential to drop, or situation like sharp edges, edges like pointy, okay, uh, like other situation like spark, okay, spark, I mean the spark from machine, okay, and then fuel plus, okay, fuel plus oxygen uh, plus heat, so it may cause fire. Okay, so that fuel, not fuel, especially unattended fuel, exposed fuel. Okay, so that may cause fire. So that is a situation. Actually, there's another or act is also the source of act. So in this two, one or two is basically source of situation. Situation. But there's another thing is need to add is source of act. Source of act means that is have to do with human behavior. Okay, human behavior. Uh, like working uh, over time. Okay, working over limit without proper rest. Okay, working uh, uh, like 12 shift, 12-hour shift, for example, um, or horseplay. Okay, playing around, okay, without uh, basically uh, obey the regulation, okay, in the workplace, for example. So those are example of source of act. So the hazard can be source of situation or source of act that may uh, uh, they may pose a potential harm, or may cause a potential harm to people or to the environment, or to the uh, asset, okay, asset or our building or structures. Okay, so characteristic of hazard is the risk. Okay, risk. Uh, when we identify the hazard, okay, whether it is a situation of an act. So we need to characterize it with the risk. So we can, this is a quantitative uh, characteristic lah. Means that we can put a number, okay, on the risk of a hazard. Uh, so the risk is basically equals to the severity plus the probability, sometimes likeliness, okay, sometimes frequency. It can be S times L, or sometimes S multiply with the F. Okay, this is a quantitative number we put, and we categorize according to the level. Okay, so that is basically the definition of hazard and the characteristic of hazards. So an incident, basically an undesired or unplanned event. Most likely an accident is cannot we cannot predict an accident. Okay, an accident, it may happen outside our desire. Okay, but if we fail to identify hazard and do the risk assessment, it will lead to uh, high severity. Okay, even it can lead to uh, fatal, or a lot of loss. Okay, so hazard, okay, represent a potential for accident to occur lah. Okay, for example, this one, an elevator shaft with the door stuck open. So that is an uh, uh, is a hazard, but it is a source of the situation. Okay, the source is situation hazard. So this is a situation hazard, or a hazard caused by situation. But necessary may no accident may happen, but it has a possibility. Okay. Okay. So we, when we talk about hazard, we need to think about the situation or the worst case scenario lah. Okay. We may think of if anyone who is okay, blinded to walk through the open door. Okay. So there's a possibility that people will walk into that open shaft door, and then um, and then we have to take a precaution. Okay, I will discuss about how we assess, okay, the hazard, and then how the step or the measure that we can use, okay, to mitigate the hazard. Okay. Uh, okay, so again, in the hazard also we have to uh, consider the source of act, okay, as the cause of hazard. Okay, like I have given you some example before. Okay, risk management. Uh, is the identification, assessment, and prioritize the risk, followed by the coordination. Um, so, so this is a step how to minimize, monitor, and control the probability of the events, the unfortunate events, to maximize the relation of opportunity. This uh, in some of the definition, risk and risk assessment uh, and risk analysis is can be done by to help us to define uh, the quantitative or qualitative value, okay, come from a hazard. Think you think this is this keep thing also nice keep one. Okay, so hazard identification is the systematic process to determine a system hazard. When we look at the complex and sophisticated process, uh, and then when we identify the set of define the set of system state that we need to avoid. Okay, and so when we identify the hazard, okay, we need to identify the control measure. Okay, and 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 we will look into whether uh, possibly to avoid the hazard, but most often we cannot avoid the hazard, because the if we want to avoid the hazard, the thing that we can do is to not doing it. Okay, but like for example in the industry, we need to do the process, we need to set up the factory, okay, because we need to produce, okay, the item or the product. So what we need to do is to uh, identify the hazards, okay, and do the uh, control measure, okay, which with the control measure we can reduce, okay, the severity, or we can reduce reduce the risk. So basically we cannot totally uh, have a zero risk. That is impossible. But what we can do, we can reduce the risk level lah. Okay, but this first method is to identify the hazard. Okay, so when you want to identify hazard, we you need to know the type of hazard. Okay, they are basically the hazard can be classified into physical hazard, okay, like falling objects, uh, per spinning object, also, okay, fire also included in the physical hazard. Okay, other than that we have chemical hazard, then we have uh, biological hazard, noise hazard, and even ergonomic hazard. Even psychology is part of the hazard. Okay, but when to talk in industry, okay, most often is like physical, chemical, and noise. Okay, so we need to identify the hazard, like physical hazard, the hazard in the system itself. So hazard analysis is to identify the hazard that exists within the system, and then determine the chain of event that could possibly lead to each hazard, and then determine the consequences. Okay, consequences. This is basically what is the risk. Okay, so the risk, and this is what the cause effect. Okay, and the risk, and then this is basically the control measure. So you need to identify the hazard that may happen well, now we are talking about the system. Okay. So in general, okay, you are the expert lah. Okay. Like you are an expert of design, control system design. Okay. So now we are talking about instrumentation and measurement. We're talking about valve. So in the system, they have a valve. Okay. So the probability, of failure of valve, what is the probability? Okay, the probability function on demand PFD can be calculated from the datasheet, for example. So what will cause, okay, from the apa from the valve failure, for example. So if there's a valve failure happening, so what should we do? Okay, one of it is to install a safety instrumented system lah. We will look into that later. But now you need to know how to identify the hazard in your system itself. So your system, okay, may have a moving parts. Okay, and then the moving parts have a limit. Okay, what? Okay, then you have to identify. And then this is called as the PHA, preliminary hazard analysis. This a phase that uh, of overall safety life cycle carried out at the requirement stage. Okay, so the purpose of PHA to identify safety critical area of the system, and to identify major hazard that must be controlled or eliminated by from redesign. So the PHA must be carried out by all system and subsystem, especially during the designing process. Okay, so during the designing process, so you need to sit down and have a team that carry the task to do the preliminary hazard analysis. Okay. Uh, so the task is this. What is have to be done is to a brief description of the system and the environment. For example, what is the purpose of the system? Purpose. So environment, what are uh, like the temperature, okay, the if the pressure or will emit gas, smoke, and etc. And then overview of the system function. Okay, system function. So basically in process control, remember we in the yesterday, in a control system, okay, at least must have an input. Okay, the subsystem, so you have the sensor, okay, and then you have a logic solver, which is the controller, and then the final control elements, which are the actuator, and then the control, okay, the variables. Okay, so you need to identify the function, and then what is the safety feature of the function. For example, the control system, okay, have an alarm, okay, alarm. So that is its function. Uh, And then the safety objective of the system have to be identified, and justification of the risk and integrity level assessment. Uh, and then you need to calculate the safety levels. So usually the safety level have 4, 3, 2, 1. The safety level based on the risk. Okay, and with each level, you have it will determine the uh, safety level of your system. Sorry, safety level. The probability function, the probability of failure, probability function of failure, PFD. Okay, PFD means that for each function of the system, okay, uh, the PFD must be okay. Like for example, as for I think it's 0.1, 0.01, and so on. 0.001, 0.0001. I think it's another one. PFD, probability function on demand. Uh, of course, uh, it will this PFD, okay, will come system function like a valve. Okay, valve, it has a PFD. You can check from the data sheet. Okay, so when we have identified the safety level, so we can choose, okay, the valve with proper PFD level. The thing is that higher PFD means higher cost. So we have to like balance, balance, okay, the cost of the system that we have to spend to provide our safety safety system lah, or safety instrument system. Okay. Okay, and then the other like source of any data and the analysis and the documentation is also very important lah. The main step is to do the prerequisite. Okay, uh, okay, the prerequisite like before the prerequisite do the meeting lah. Uh, with in the designing process, and then do the hazard identification. Okay, the hazard identification on the source of situation that will may probably cause the failure of your function. Okay, consequences. Uh, Consequences. This is for basically what are the consequences like fire. Okay, explosion. Okay, or damage or injuries. Okay, and risk ranking mean that calculate the risk and do if and if the risk is at the extreme level, so there must be a follow-up action. You have to give a timeline to reduce how or plan how to reduce the risk or to eliminate or okay, to eliminate the existing hazard into so that so the risk is, can be reduced. So these are the prerequisite basically. Okay, establish the team. Okay, define uh, the system to be analyzed. Okay, this is process engineer task. Okay, and then to do, okay, to evaluate, and then in the prerequisite also to identify the system breakdown. Okay, and hazard identification. So all hazard must be identified. So all the parts or the operation, the maintenance, the safety, so on. So you have to identify lah. Okay, hazard, remember, is a source of condition, okay, that may possibly cause an harm. Okay, so in this case you are the expert. Okay, if your function like a valve or for example a boiler or so, a heater, okay, a roller, for example, roller or a stamping machine, or furnace. So the list go on lah. Okay, in the industry, so your conveyor, for example. So there has a hazard. So you have to identify the hazard. Okay, and then when you identify the hazard, you have to identify the cause, the effect that may happen if the accident happen. Okay, the situation. Okay, so this is the hazard checklist. Okay, I've given you some idea before the type of hazard. So this is an elaborate of the hazard: physical hazard, like mechanical hazard, electrical hazard, thermal. This is mainly physical hazard, vibration, radiation. This mainly physical hazard. Okay, but don't limit into this. You can expand like chemical hazard, noise hazard. Yeah, this is noise hazard. Okay. Okay, so frequency and consequences estimation. Uh, so the risk is related to accident. Event is a function of frequency and event or severity. So risk is equal to the function or L multiplied with S. L, likeliness, or the likeliness of frequency, likeliness. Okay, likeliness. Okay. And to determine the risk level, we need to estimate the frequency and severity. Severity, we will see some example later if we can. Then we can identify the risk level. Okay. This is the risk matrix. Uh, and this is the frequency. Frequency, and this is this is the frequency, and this is the severity. Okay, frequency or the likeliness. Okay, 1, 2, 3, 4, 5. Okay, this is the frequency. Frequency, or sometimes likeliness. It's the probability of the event to occur. Consequences. Okay, this is the level of consequences. Okay, minor, major, critical, and catastrophe. Okay, so this is the level. Minor, like for example, will cause damage. Okay, minor damage. Okay, major, like cause injuries. Okay, that maybe can recover over the time. Okay, like critical, permanent, will cause permanent injuries. Permanent injuries like broken hand, okay, or uh, hearing loss. Okay, catastrophic, basically death. Oh, no, basically disaster lah, catastrophic. Okay, likeliness or frequency is how 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 many time do you think that condition may appear? Like you can relate with the number, or like for example, number of people access that process or that situation. Okay, you can relate, or how is that place is uh, exposed, for example, okay, to open space. Okay, so that is likeliness lah. Okay, so when you do the risk, okay, risk is basically the likeliness or frequency multiply the severity or these are consequences. Consequences. Okay. This is the severity lah. Severity. Okay. So for example, 1 times 4 is 4, 2 times 4, 8, 3 times 4, 12, 4, 4, 16. This is 20. 4 times 3, 12, 5. This is 15. This is 10. This is 1 times 3, 3. 1 times 2, 2, 1. 2 times 3, 6. 3 times 3, 9. 2 times 2, 4. 2, 3, 4, 5. Okay, 3 times 2, 6. 4 times 2, 6. Okay. So, what we have, when we have from the hazard, okay, when we have identified the risk, okay, what is our impression? What is our action? Okay, so first you need to see the level of the risk. If the risk is blue, if the risk is green or yellow, that means the operation can still proceed. Okay, in the process, the process can still proceed, but you have to like for green, you have to observe lah, do the observation or find a way how to reduce. Okay, at least the put an action lah. If yellow, okay, means that it still can proceed, but will with precaution and correction action or control measure. Okay, control measure. Okay, so the control measure, there are hierarchy of control. Okay, so like for example, you in this case we use engineering controls lah. So today we going to look at engineering controls. How in the system when there are hazard, Okay, how do we apply engineering controls when we design the system? Okay, but if the level is at red, so system must stop, and we apply the engineering control. Okay, then after the problem is rectified, then we can resume the process. Okay, so remember that green and yellow still can proceed. Red, stop. Okay, no process, stop process. But if in green, normally we don't apply the engineering control. Okay, because what happen if you apply the engineering control? Okay, you will only incur uh, more cost into your system, but that will basically increase your safety level. But it will actually okay, because you want to balance with the cost and your profit, right? But when the process or the risk that we calculate is in the yellow, so we need to do the engineering controls. We will look into that. Okay. So this is the result. Okay. For example, okay. Here, okay, one number. Okay, the hazard. Okay, like for example, fail uh, fail valve, potential fail valve. Okay, uh, fail valve, and the accident will cause, for example, what is cause? Okay, fail valve accident. What will cause water damage? For example, water damage. We take a tank vessel is filled with water lah. Okay, okay, water damage. Okay, will flood the area. Probable cause, yeah, the cause of the low maintenance lah, for example. So the action is there are few things that you can do lah. Uh, Proper maintenance, okay, or engineering control. There's a hierarchy of control. Okay, but maybe we talk about engineering control, so safety instrumentated system lah. Safety instrumentated system. Okay, probability or frequency, you put like uh, 3. Okay, it can be probable lah, like 4 lah. You put 4. Okay. Severity, it depends on the situation lah. Okay, for example, the tank or the vessel is around a power subsystem, for the power supply or power other equipment lah. Okay, so it may cause fire lah, cause fire damage, or maybe it will cause injury. Okay, okay, you can put uh, critical may not be because people maybe it's far away from people. It may cause fire, for example. You put the maybe severity, you can put this 8. Okay, you put 8. Okay, so sorry, probability is 4. You put 2 lah. The severity maybe you put 2. So that give the risk level 8. Okay, 8 here. Okay, okay. 10 means that it is in the yellow zone. Still process can can go on, but you have to do the action lah, the control measure, okay, installing the safety instrument system. But if the safety instrument system, okay, so you don't put the probability 4 lah, okay, you reduce the probability to 2 because you have a SIS already, okay, okay, and then we give some comments lah, okay. Positive, okay, safety lah, good. That's the main purpose. Safety is the number one priority. Negative, hazard must be foreseen by the analyst because it may only come through experience lah. It's hard to instantly understand what is a hazard. Okay, like we have to go through experience lah. And the effect and interaction between hazard are not easily recognized. Means that it's maybe subjective. So if but the worst thing is if this is not in place, okay, as a safety in PHA team, you can suggest and then okay, suggest and then put a proper safety system lah. Okay, approach to hazard analysis as a HAZOP. Okay, I think I don't go into the HAZOP. Okay, but we go into this safety instrumented system. Okay, so safety instrumented system. Okay, remember that. Okay, I have explained. Okay, when we identify the risk at yellow zone, so we need to do a control measure lah. So control measure, there are hierarchy of or different step of control measure. And the safety instrumented system is basically the engineering control in the hierarchy or the control measure. Okay, so the safety instrument system is basically depends on the correction function being performed. So it is depend on the correct function order being performed is basically an a layer, an extra layer to the existing process control system. Okay, there's a standards. Okay, IEC 61511. Okay, how a safety system is defined, how it is put in place, and also the requirement lah. Okay, one of the interesting requirement in safety instrumented system, the safety instrumented system must not be connected to online system or on internet to avoid any problem like hacking. Okay, and the safety instrumented system must work independently. Okay, it must not connected to the actual control system. It must work independently. Okay, so again, the typical component of a control system. Okay, remember we have typical control system. Let's say in this example, so controlling the flow in the pipeline lah, for example, okay, flow of volume of flow. Okay, so what are the elements? First, must have a transducer. Okay, that's the first element. So the transducer converts the physical parameter into electrical signals. Okay, so the physical parameter in case is flow rate, and then convert into electrical signals to a logic controller, or called as the logic solver is called as the controller. Okay, the second element, which make decision okay, based on your set of rules. Okay, you want okay to control the, for example, the flow at certain limit or threshold, and the third is the final uh, control element or final element or output device. Okay, is or actuator. Fine. Okay. So in this case, okay, we have in this case we have a valve. Okay. So that's a typical control system. So it make decision okay, based on the setting that we apply. Okay, so uh, a safety instrumented system, okay, like I so said, it must operate independently. So it is not a part of the control system. Okay, it actually add a protective layer to existing system. Okay, but not a part of the control system itself. And the assistive simulated system, again, it also must have a sensor, okay, a logic solver and actuator. So the purpose is not, it's not to do the control or the controlling process, okay, but it's the purpose is to okay to do an action, okay, perform an action when there is a uh, limit that has been exceeded. For example, like flow has been exceeded at certain level or limit. Okay, so the sensory instrument system is an independent system and not a part of the basic control system. Okay, and each subset must meet the safety instrumented level target. Okay, safety. Sorry, safe SIL is safety instrumented level. Okay, it must uh, fulfill the estimated um, level we determine from the risk. Okay, okay this risk level here. Okay, and and so the subsystem must meet the SI level. So like I mentioned, the SI level. Okay, there are level 4, level 3, level 2, level of 1. Okay, and we choose okay the quality of the subsystem based on the SIL that we determine. Okay, like and that level we is called PFD. Uh, Probability of failure demand. Okay, and then the number, okay, 0.0. Maybe I'm okay. 0.001. Okay, so the PFD. So each element okay have their PFD. Okay, they lower the PFD values means that it is much more reliable. But the thing is that if the PFD is lower, means that the cost is much higher. So we have to balance. So the subset must meet the SIL, safety estimated level that we set. Okay, be careful on that. Okay. This hazard, I think we have covered in okay hazard again. Uh, 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 com, Potential causing to harm physical or chemical. But this definition is more on source. Okay, source, because act we hazard in this term not on the act, not include the human action lah in the hazard, but it's okay. Okay, okay. Risk again. Okay. Uh, so they consider this system. Okay, a system, a simple system. Okay, a basic tank level control with overflow hazard. Okay. Uh, so we need to do some understanding on the PID diagram lah. PID diagram. So we look in this in the diagram. So we have basically a vessel. Okay, which we transfer fluid into the vessel. Okay, and okay, so this system have okay control system. Okay, and which the first element in okay important is the level transmitter, which measure the level of the material inside the uh, vessel here. Okay, and the signal output from the level transmitter sent to the uh, level controller, and then the level controller send electrical to convert the electrical signal into pneumatic signal to control the valve. And they have a control valve. Okay, so this is the second element, and then this is the third element of the control system. Okay, and it has this is a safety valve or the release valve to release the valve light. So this is also a safety feature. Okay, so this we have this is a basic control system, right? So we want to now we want to apply a safety instrumented system. Okay, as an additional to the current or to the existing control system. So as you can see here, first, okay, by installing another level, okay, another level transmitter here, okay, for the safety instrumented system, and go to the logic solver, and the logic solver basically control another uh, valve, okay, flow valve, fail close. Okay, so this is the second element of the safety instrument system, and then the third element. So see how the valve is placed before the actual control valve. Okay, so this safety instrumented system work independently. Okay, work independently and does not rely, okay, or does not uh, connected to the main control system. So that's the rule. So this safety instrumented system add another layer of safety to the existing control system. Okay. right? And this one, I think I can, and I it's okay. Also, I think this is not uh, like I say, then the purpose is what we want to reduce, okay, the uh, risk, okay, from the consequences, sorry, the risk, okay, from the likeliness time the severity or the frequency time the consequences, okay. I don't know. So basically if the risk is high, it so means that we have to take action. So the risk basically depend on the risk matrix where I've shown you before. Um, so basically if the uh, level of the risk below above this line, okay, so means that it will cause like for example fatal or serious injury and minor. This is just another example lah, uh, of this is another representation of the risk matrix. Okay, remember the risk matrix. Okay, so the objective is to reduce, okay, the risk, okay, uh, by reducing the frequency or the consequences. Okay, like if we apply, okay, okay, the safety instrumented system, okay, the consequences will go down, okay, and also the frequency also will go down. Okay, so the risk, okay, that we estimate will determine the safety instrumented level, uh, and then we when we apply that instrumented safety instrumented system, so most so by principle, so the risk will go down. Thing. Oh yeah, this is what I mentioned before, like in the first place, the when we determine the safety of instrumented level, okay, so we need to find the probability of failure on demand, PFD, okay, of each element. Okay, the PFD of each element can be determined from the data sheet, like from the VAF. So it will have the PFD. So if the safety uh, safety instrumentated level that we identify, like say for example at 4, it means that we must use element that have very level of a level of PFD at 0.0001, for example. Okay. Mm, I think it's uh, so I think no. Right. Right. So I think that's the in this just want to the most important part of the safety instrumented system. You must understand, okay, the concept of installing, how to install, okay, a safety instrumented system lah. Okay, so let's say maybe we do some other example. Okay, simple example maybe. Um, we can have a tank, okay, okay that receive water, and we want to control. Uh, so we have a place a control system. Okay, so typically when this is uh, control system, so you have a level transmitter transmit signal to logic controller, controller control the valve. So again, when we have a instrumented control system, so we introduce okay okay logic solver, okay, and also the independent valve, which receive the input from another level transmitter, okay, which work independently. Okay, so that is one example lah for safety instrumented system. Another example where you have a separate system to control the level of the water in the tank. Uh, so the safety can be further improved, okay, okay by having another release valve. Okay, so that uh, this is fail close, this is fail open. Okay, so to make sure the pressure, okay, or the water level, okay, okay, not okay, or to make sure the tank is empty when there's failure happen. Okay, so that's one example how safety instrumented system can be used. Okay, so I think we only have another 15 minutes to spare on the actual lecture. Uh, just to add some information, uh, eh, maybe I will share, okay, like the uh, so the, like for example, the tutorial for extra tutorial, if from time to time I will share in the group and then post into the YouTube. Uh, so officially we have finished, okay, basically our content. Uh, Again, I want to uh, tell you that will change the format of the assignment submission for this class, whereas maybe with this presentation we'll conduct through recorded video lah. So rather than having another session where we meet, and also if you have any question on the uh, content, okay, you can always ask me, okay, during the before for the final exams. And also the second test will have to no choice, but we have to maybe again we will do the same. Uh, I mean on Saturday, but not this coming Saturday. We'll announce because the let me check the schedule. Um, this your now is like still second week of after the semester break, basically. Or basically we are now at week 9. Okay, or week sorry, week 9. Basically, still have a long way to go. So the final, even the final is going on, I think in the February, if I'm not mistaken, right? So this class is officially settled, but from time to time, okay, I will share the uh, tutorial, or will, and also if it is required, we will we set up another uh, extra class lah if necessary. But all the content I have include, okay, and then I will share you the recording as usual lah. So we will continue to communicate, and also will return back your test one, okay, and also if you have any question, you will ask, okay, regarding the test one and so on, okay. So I say thank you everyone for staying during this basically class, and I think it seems to be not over yet. Still have a long way to go. It's just we will okay, communicate from time to time through the uh, WhatsApp. Okay, so I wish all the best, or good luck to everyone. So you have more class to cover or to go through. Okay, so again, thank you very much. Interim report, I will try to look at it this week lah, but no rush. I will look into, I know the date, I will look into back the date that you're supposed to present, and I will, okay, okay, make sure that my comment will come before your submission, or from the actual submission lah. Okay, right. So thank you everyone.